Hey everyone, today I'll be talking about the programs and setup and all the features in my smart doorbell system. So I'll show my actual physical setup at the end of the video. For now, I'll go through my programs as well as the demonstration. You'll get to see a video. I'll explain the different steps I took. Yeah, that's basically it. So let's talk about what this program is. Mask location. This was used to help me determine the bounding box that I would use for my masking. So as you can see, I will take an image that I pulled from my setup. That is what I will be looking at, which is our door. It's looking directly at the door, and I wanted to use use this section to find the bounding boxes that would then indicate where the x and y coordinates are of the top left corner of those bounding boxes, and use that to determine the mask. As you can see here, this is what my setup looks like. I can use this to make the bounding boxes, and I will generate a value for me. So 172, 36, 149. Now, for the actual pipeline, let's talk about that. So let's ignore the top part for a second. Let's go to my function, def mask image. First, we're going to generate a mask of the size of the image that we're looking at. And from there, we will look only at the points or MP array. We'll we'll fill up the mask with 255 and do a bitwise, or fill out the area around the points with the fill convex poly and do a bitwise and the things inside of it, or actually opposite way around, we'll fill in a black area, the area with the black, and then we'll do a bitwise and the areas inside that will then turn into the image, and the areas outside of it will then turn into black. From there, we resize our image using sized to 300 pixels wide, and then from there, however it's scaled, we'll gray out our image using BGR to gray, and then we'll do apply blurred. I use 11 to 11 because that is the usual one we've used, and it's worked pretty effectively well for me. It blurs out as many of the pixels to a very simple, smooth gray color, and that increases the performance because we're only looking at a few colors. We don't have to worry too much about that, and we turn masked and blurred. Now, throughout this program, we'll do a while true. That essentially just means while true, this will keep on going. So this will keep on going forever, and it'll tell me how many times through our loop we're going through. From there, we'll use the built-in RPI cam still to do a time-lapse image picking up. So we will first, of course, we set the width and height to 1280 720. -N just means no displaying of the actual preview camera. We do a timeout of 1500, time-lapse 500, and we'll generate our test image. The reason I did this timeout 1500, time-lapse 500 is I assumed when we were using, based on what we were learning, is Raspbian, with the Raspbian cam, is that you can set it to timeout 1000, time-lapse 100, 1000, and it'll take a picture at the beginning of the time-lapse and the end. Turns out that doesn't work with RPI cam, so you need to take however long you want if you want to have two pictures within around a second time frame, you need to set one up in the first 500 in the first time lapse second, the second time lapse second. So it's a little weird, but I wanted to take pictures presumably every 500 seconds, and so I did that by doing this, and 500 milliseconds, and I did that by setting the time lapse to 500, timeout to 1500 because the first 500 doesn't count. Only after that then does it start taking pictures, and then I'll have captured the first and second image, and it will have generated those images. Next, we are going to read in those images through the test 1, test 2, and do the whole masking process. And finally, we're going to compare those two images. This is where the actual smart doorbell happens. This is where we go through each of the pixels of those two images, and we'll check if the grayscale values, the difference between them, absolute difference between them, is greater than 50. 50 is 1/5 of the entire grayscale scale itself. So if there is a 20% change in the values, that is more than enough to start saying, hey, we need to flag this. If enough values are flagged, so do a detector 30,000, well, if there's enough pixels being changed, the total number of pixels being changed, that is when we'll say, hey, there's something at the door. right? We want to sum all these pixels up. We'll get our detector total. If that detector total is greater than 30,000, hey, we'll be like, hey, we saw something at the door. That is we should let the user know. And I chose 30,000 because it seemed pretty appropriate for this, based on what we had learned. And yeah, so now that we've found out there's something at the door, we're going to create a 10-second video of frame rate 25, and we're going to convert it to MP4. So this is the process that does so. We are also going to let the user know at what time that this has happened at. So it'll the year, month, date, hour, minute, second, and from there we will have converted the MP4. We're going to write the grade 1, grade 2, mass 1, mass 2 to our Raspberry Pi, but we're not setting that. What we care about is test 0, test 1, the original pictures from the time lapse, and we're going to send it to a throwaway account. We're going to send those pictures and email it to the throwaway account, test 0, test 1, just for the purpose of this project. And it will send our video, it will send our 2 files, and it'll tell us that we have sent the email, and from there, it will continue on. That is basically the entire process. So let's let it run. I'm going to show us running the entire thing. So here is our thing itself. I'm going to, so as you can see, we have our doorbell script. I am going to run our script, and then we shall see. Well, let's let it run. Yeah. So now it's starting to take pictures again. As you can tell, we are consistently looping. We've gone through 2 loops already, and as it will keep on taking these pictures again and again till it sees any actual change. So there's detector total 0, hasn't been any change. So I am going to walk through the sensor, and you will be able to see me in that sensor. All right, give me a few seconds, and you will see me. And I'm currently walking through. So yeah, as you can see, we have peaked the values. Now you can see me in this video. I'm here. It will send this video to my throwaway account. And yeah, finish converting the file. Once it's done sending, it is sent, and it's back to taking pictures. So let us check if that file has been sent, shall we? Oh, look at that. So we found activity. We have our 2 pixels, two pictures, 0 and 1. See, my laptop is in that picture. We also get to see a video. So let's quickly download that video and check it out. Wow, that is me. I am talking in that video. Pretty cool, right? So yeah, now you can see that this is our setup, or this is what the detection pipeline does. I think definitely we can improve on this, but my assumption is that when a door opens, the door is gonna open really quickly, and someone could easily run in. So I wanted to take pictures quickly, so maybe we can have reduced the pixel width to optimize it a bit more. Maybe we can increase the blur. That could have been, it wouldn't really make much of a difference though. It would end up just blurring it more. Maybe it would reduce the pixel density, but who really knows? If we wanted to reduce the pixel density or pixel quantity, and then also increase, keep the blur the same, or increase the pixel quantity and then increase the blur as well, we're just getting a lot more pixels. It's not going to make much change, but we can technically reduce the size of the images. That is definitely an option. Definitely a better camera, a wide lens camera. You can get much more bigger view. This will be better in actual house environment where you have a backyard. You want to make sure people aren't doing anything in your backyard. So a different mask for that, a different lens, maybe a fish eye lens. You'll get to see more of the actual land and everything and like that. There's not many recommendations of how maybe the algorithm works. Honestly, I think the algorithm works perfectly fine. I will say that this pixel compare thing could be optimized a bit more to be faster. There potentially are ways of doing a comparison between each pixel in linear time using one of the functions that are built in. But as of right now, this is a very simple, straightforward approach. It's very legible to compare. Other than that, I think that's really it. I think this is a very impressive pipeline for looking the smart doorbell. I will right now after this I will be showing my physical setup. And as you can see here, this is my physical setup. It is our tripod stand with our camera in the front. I'm gonna quickly go to it. Yeah, camera in the front. And this is our door. So realistically, it only captures kind of the top or 70, 80% of it, 80% of the door instead of the full door, but it's more than enough to detect if someone's entering our door and send me an email whenever that happens. Yeah, that is basically it. All right.